Moving on to our next presenters, we're pleased to have two experts on the future of space travel join us today from Lockheed Martin in Denver. Tony Antonelli is a former NASA astronaut, and he will be joined by fellow engineer Chip Wood with a presentation about our plans to return to the moon in the future and then go on to Mars.
Well, thank you for the opportunity to talk to you all at the FutureVisions Symposium. My name is Chip Woods, former alumni from Colorado State University, and proud to be wanted to talk to you today a little bit about the project that we're working on. Lockheed Martin. Orion is the name of the project. And today we have Tony Antonelli with us. He's the Artemis II director for Orion. I'll take it away, Tony.
All right, thanks for having us. I'm really excited to be here. So we'll talk to you a little bit about what we're doing today, and then the near future. And then if you're interested, maybe in the Q&A, we'll talk more about the farther out future. But we got a national mandate to go to the moon. It's to land the first woman and the next man on the moon by 2024, and we'll show you the part we're playing in that grand endeavor. So the program is called Artemis. Artemis is Apollo's twin sister, and if you start in the upper left, our next flight is Artemis 1. This will be a uncrewed test flight, and the farthest into deep space will have sent a human-rated spaceship ever. So it'll go into cislunar space out past where the Apollo missions went, and that is currently scheduled for just next year. And then following that is Artemis 2. This is if you caught my job title, I'm the Artemis 2 mission director. So this is a spacecraft that I spend my days trying to get built and tested. It's in Florida. We'll show you pictures of it here in a couple of slides. And this time we'll put people on the first Orion spacecraft and send them out into deep space. No human has left low Earth orbit since 1972. So for many of you in the audience, this will be the first time humans have left low Earth orbit in your lifetime. And when I say low Earth orbit, I think of 200 to 300 miles above the surface of the Earth, where the International Space Station is, and the Hubble Space Telescope's a little higher. So think 200 to 300 miles, and the moon is 250,000 miles, so like 1,000 times farther. If you think about that, it's the difference between taking a couple of steps and walking a mile, or the difference between driving to the corner store versus taking a trip to Europe. So a little bit different journey, and Orion is designed and built specifically for those deep space missions. And then following Artemis 2, it will be Artemis 3, and this will be the mission where Orion takes the crew into cislunar space, and they dock with the human lander and transfer into the human lander, land on the surface of the moon, and then launch back off of the surface of the moon and rendezvous with Orion, and then Orion will return them back safely to Earth. All right, so this is what we're working on today. So the Artemis 3 mission, I'll say, is the near future, but Artemis 1, pictured there on the left, that was in a test chamber in Plum Brook earlier this year, and now Orion's at the Kennedy Space Center in the Neil Armstrong Operations and Checkout Building, just a few completing her assembly and test and getting ready to be stacked on the SLS rocket when the rocket shows up to Florida. So really exciting time for the Artemis 1 spacecraft. The Artemis 2 spacecraft in the middle is what I work on. She's she's coming together. The green there you can see is just the primer on the aluminum pressure vessel. I was talking to Chip earlier about the little white covers in the middle of the picture, in the middle of the spacecraft, are basically covering up the windows. And so whenever I look at the R2 spacecraft, my eyes instantly go to the windows. So I can imagine that Artemis 2 crew floating around in this spacecraft that you see here in this picture, out past the moon, looking out those windows, seeing the moon up close, and also seeing Earth like the big blue marble she is when you're that far away from home. I can even imagine their nose print right on the windows as they get closer and closer to try to soak up that view all the way in until they bump into that window. And we'll make sure they get them cleaned off for any of the pictures they take for us. But Artemis, a real spacecraft, she's also in the operations and checkout building getting assembled. We're adding the propulsion system today and also the life support equipment. And then as soon as we get that work done, we'll add all the avionics, including the displays and controls. And then we don't stop there. Off to the right of the page is the aft bulkhead out of a machine shop, and also one of the cone panels. So the hardware that will make up the pressure vessel is already being machined, as well as a lot of the other components that come together to build the Artemis 3 Orion spacecraft. And then in the bottom picture on the right is the team of folks that build these spacecraft, and these aren't our first spacecraft. In that picture is Exploration Flight Test 1, which we flew in December of 2014. Artemis 1 in that picture from a few years ago, and then also the structural test article. So this team has built a few Orion spacecraft before, so they're ready to shift into to high gear and a production mode and start cranking these spacecraft out on the order of once a year.
Thanks, Tony. My role on the program is the affordability and producibility manager. And one of the ways that we do that is through the use of technology. One of the technologies that we've been working on here recently and that you're going to see here in a video is what we call the HoloLens 2. This graph kind of shows you some of our technicians that would use this technology. This technology is being developed with Microsoft and Lockheed Martin. And we both see really tremendous advantages with using this technology. What it does when the technician puts these goggles on, it really blends the two worlds, the physical world that the technician is assembling a spacecraft, and then the goggles have the ability in the HoloLens 2 to overlay the holographs on other pieces of hardware, helps in alignment. It really speeds up the process of assembling the vehicle. Just for an example, we had a technician that typically takes like 8 hours to perform this task. We had the technician use the HoloLens 2 goggles, and that task was completed in 45 minutes. So not only does it save time, but it saves cost because we can assemble a vehicle quicker. In addition, all the trials that we've done and have gone through with using this technology, we've recorded no errors. So the technicians, not only, it's really the trifecta, it improves cost, it's faster, so schedule is better, and it improves the quality of the product. So it's really a tremendous benefit to what we're doing on Orion. I have just a quick video here of a crew seat assembly. And so what you're gonna see is the camera has the HoloLens on, and you can see the hardware there. That's the back, strong back of the crew seats. And you can see the holograms of the rest of the structure. And so the technician can select which assembly he wants to look at. And you can see the HoloLens puts a graphic, in close proximity of the actual hardware and demonstrates how it is aligned, what pins you need to use, what fasteners, so forth and so on. In a normal case, like this gentleman, this technician is doing here, you see that screen on the left there would be work instructions that the person would have to look at a 2D drawing and then mentally translate that into a 3D environment that he's working in. Well, the HoloLens, again, mixes those two and combines that. All the work instructions are right there in that screen that you can see. And so it shows that the brackets and the fasteners and everything that he needs is right there for him to use to install. So again, it really cuts down on the time to assemble a spacecraft, and in this case, a crew seat. Interesting thing about the crew seats is that these are all customizable. It's very self-custom to the specific astronaut that's going to fly in this. So we can accommodate the smallest female all the way up to the largest male by just adjusting where the seat is and how the seat is assembled. And I love this example. The HoloLens recognizes the hardware that they're going to be assembling onto the crew seat and walks through it, exactly how it's oriented, what it's going to take to assemble it. And so the technicians can do that 3 or 4 times before they actually go and perform the activity. Hey, Tony, the next slide is the crew training and preparedness. You might know a little bit about this activity.
All right. So the both the exciting part and the challenging part of human spaceflight is, of course, the humans. Orion's designed, of course, with the crew in mind. The human machine interface when you're trying to preserve all of your options for flying the Orion spacecraft definitely have to be taken into account when you're doing the design. So Orion has the capability to fly autonomously. She also has the capability to be flown, I say, from the ground. So the Mission Control Center can fly the Orion spacecraft, and then also the crew inside. Like I said, the Artemis 1 mission will be uncrewed. So it'll be a combination of autonomous flight and controlled from the ground. And then on the Artemis 2 mission, we'll have all 3 depending on the phase of flight. So you can see on the left how the crew sits in Orion for launch and landing and other dynamic phases like docking and that sort of thing. In their ascent entry suits, or those orange suits. These are what the NASA calls the modified ascent entry suit. One of the key features of the modification and one of the stringent requirements on Orion is a normal trip to or from the moon is about 3 days. But under some abort cases, if something else is going wrong, it can be as long as 6 days. And so Orion has the capability to button the crew up in their suits and return them safely to Earth, even if the return trip is as long as 6 days. The middle picture, of course, in addition to ascent and entry, the crew has to live in Orion. They'll live in just Orion on the Artemis 2 mission, and then they'll live in Orion until they dock with the lander to go down to the surface of the moon. And so that you can see the crew's got to be able to get in and out of their seats, in and out of their suits, and then reconfigure for a living environment. Additionally, from a human perspective, Orion's the first spacecraft ever with a radiation requirement for the humans. And we modeled this requirement off of a solar storm from the early 70s. And so the crew has the capability to reconfigure the Orion spacecraft, basically using all of their equipment and supplies to build a radiation storm shelter, if you will, and they can ride out a radiation solar storm inside Orion. And that's brand new, never been done before. And in addition to that, again, under normal circumstances, you're 3 days away from safely returning to Earth. So radiation hardened, redundant, reliable avionics, and life support equipment, everything you need to stay alive until you get back to Earth. On the right of the picture, we design and build and then train for all different circumstances. So the picture on the upper right is the crew doing an unaided egress on the launch pad. The white fairing over the outside of Orion is part of the launch abort system, which has its own hatch. And then you can see the crew climbing out of the Orion side hatch. And then Orion's designed to land in the ocean on a targeted landing. You'd have the divers there to assist you, and then if you landed untargeted, you'd have all the capability in Orion to either stay inside Orion and wait for the divers and or safely egress. And we've put this Orion mock-up in the NASA's Neutral Buoyancy Lab there in Houston. This is the same place they do the spacewalk training, the swimming pool, and so we used part of the pool for this egress training on the Orion at sea, if you will.
That's great. Thanks, Tony. And Tony, I chose this as our last slide. We thank you for the opportunity to talk to you about FutureVisions, and this is really our future vision. And Tony talked about it, the blue marble that we call home out in the distance, and the ability to build a spacecraft to take humans further than they've ever gone and make this view a reality. It's exciting for us. It's an exciting time. And when you think about it, the technology and the tools that we have, the Lockheed Martin NASA team coming together, making this a reality. We're very happy to be a part of it. We're a little humbled and honored to do a small part in making this vision a reality. So thank you so much. And we look forward to the question and answers, and go Rams.
Thank you, Tony and Chip. That was really fascinating. We now have 5 minutes for questions. So if you have any questions, feel free to type them into the Q&A, and we have a few to start with. The first one here, how are we going to Mars? From the moon or from Earth?
Chip, you want me to? I guess I'll jump in and start. Yeah, that's a great question. Of course, all of us start on Earth, so it's you're starting your journey from Earth, and then it's very likely from a couple of different orbits, right? Earth sets in a pretty deep gravity well, so you could get into a higher Earth orbit and assemble your Mars transfer vehicle and Mars lander there. There's some advantages right now. The NASA's Gateway will be in cislunar space. The particular orbit is a near rectilinear halo orbit. So that's the leading contender now, where you'll start aggregating your spacecraft. And then we're still looking at the possibility of collecting rocket fuel, basically water from the moon, and splitting it up into hydrogen and oxygen and using it as rocket fuel. So it's still to be determined, but there's advantages from all those different locations. And then of course, I've lived almost my whole life on Earth, so I contend we're all starting our journey from Earth.
Good answer. Okay, next, what would you say are some of the biggest changes that the space program is facing for this moon launch versus the original back in 1969?
Let me try that one, Tony. I think back in Apollo days, right, the technology and, just think of a computer back in the 60s and 70s, right, compared to computer today. They were just really trying to stand up a human spaceflight presence. So I think today, we have the technology, advanced propellants and computing power and those types of things. So I don't think the technology is really the issue as it was back in the 70s. It's really the the support and the financial budget, required to go to the moon, it's an expensive endeavor, and you can see that, the industry as a whole is really trying to cut cost. Our spacecraft is reusable. They're really trying to make it affordable as possible, and that's really a big drive in what I do on a day-to-day basis is really trying to get the cost down, and so that the country as a whole can afford a deep exploration spacecraft and architecture, and be able to afford that as well.
All right, thanks. Next question from Max. Are there plans to build a permanent network across Earth and the moon and maybe Mars in the future?
Yeah, so I think the question was network. Yeah, absolutely. And it's, I think we'll require all the services we grow accustomed to, right? So there'll be a navigation network. I still remember when GPS was relatively new and you had to check the calendar to see when you'd get GPS in your area as the satellite constellation was still being populated. So I can imagine that going through a build-up process before you have GPS on the moon and then on Mars, like we do on Earth. Communication network, and then of course a power grid. All the things you need to live and work and function. I imagine those being done in stages on the moon and on Mars as we get more people there and keep them there for longer and longer stays.
Wow, it's crazy to think about. Okay, I think we have time for one more question. Big thinking here. What would you say is the greatest human good that this space launch is bringing to humankind?
That sounds like yours.
I was going to say, can we both have a shot? You can go first.
Sure.
If you want, Chip. I know my answer.
Go ahead.
All right. So I've gotten to see Earth from just a couple hundred miles away, which is not very far. I still admire the pictures that the Apollo 8 crew took. That Bill Anders on Apollo 8 took that Earthrise picture. I consider that one of my favorite selfies. Of course, I was a toddler in that picture, so you probably don't recognize me when you see that Earthrise picture, but I'm in there, and it's one of my favorite pictures of me from my childhood, right? I think the greatest good will be an appreciation for all the folks that live on Earth, how lucky we are to have such a beautiful spaceship that we all travel through space on, and you just have to go a little bit away from the surface of Earth to gain a whole new appreciation for how lucky we are and how thankful we should be to get to live on this planet.
Yeah, good answer, and Tony. I would just add, it's that perspective. We are explorers by nature, and the human race is. I think as we explore and reach and develop new technologies, we're going to need new technologies and new things, just like solving the water problem, right? We're going to need water on Mars, right? And to be able to take those technologies that you produce and develop and bring those back to Earth and benefit Earth, that's all the more better as well.
Okay, great. Thank you so much. We are out of time for questions on this one. We'll answer any additional questions in the window and get back to you on those.